that it will not always, it may not always, starting today, work out to be something that's factorable. So from yesterday, how do we tell the nature of the roots of a relationship? How do we check if it's factorable? It's tricky because in grade 10, when you learn to factor, we don't really give you questions that don't factor. Like, we eventually you get to it, but there's a lot of hints about when that would work, when that wouldn't work, that kind of thing. Whereas if we give you questions, you would expect them to be factorable. But at this point, it's not the case. So what do we do? Discriminant, which is? B squared minus 4AC. In this case, B is negative 8, right? Be careful of that. But when I square, that part's always going to be positive. If I put that in my calculator wrong, I mean, you guys know this. I know. Whoop. But sorry, I'm trying to bring up this. Come on, there we go. So if I go negative 8 squared, it's going to give me negative 64 because I didn't use brackets. So think for yourself. That part has to always be positive, right? Because it would be in brackets. So it's going to be 64, and then A is 8 and C is 1. Okay, so bring that back up. 64, and I think everything else is positive. So since it's minus 4, I see it's going to be minus 4 times 8 times 1. That won't do anything. Gives me 32. Not a perfect square. It's positive. Okay, so this is solvable, but it's not a perfect square. So I'm going to have to use the quadratic formula as part of my solution here. The nice thing about the discriminant too is I've already done half of the quadratic formula right there. Okay, so what is the quadratic formula? The quadratic formula is x, I'm just going to write this off the side. I'm going to do it in a different color. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a equals 8, b equals negative 8, c equals 1. And be very careful. We use this starting in grade 10 and then also in grade 11 when we're solving what we would call polynomial expressions. That's not what this is. This is a trig expression. So in this case, it's not actually x equals. It's sine of x equals. That kind of comes back to what we talked about yesterday, where the quadratic relationship, in this case, it's not a parabola. It's a quadratic relationship in terms of sine of x. Don't worry too much about that, except you have to, like for when we do the quadratic formula, it's sine x equals, not x equals. Okay, that's really important. So sine of x equals negative b, which is negative 8, which is 8, plus or minus the square root of negative 8 all squared. See how it's in brackets now? Minus 4 times a, which is 8, times c, which is 1, over 2 times a, which is 8. Okay? And this is 8 plus or minus, well, we already did this, 32. You might want to check it, but we already did it. Right? For simplicity's sake, I'm going to reduce this. You wouldn't have to. It's not a final answer, but it'll be a little bit easier to put into our calculator. It's a nice little bit of review. So this works out to 8 plus or minus the square root of 16 times 2, right? You're looking for a perfect square. You're looking for two things that multiply to 32 where one of them is a perfect square and the biggest one possible. So 4 would also work, but 16 is better. All over 16, which is 8 plus or minus, and then I take 4 out because the square root of 16 is 4. And then I can divide 4 out of everything there, right? The 8 can be divided by 4, that gives me 2. The 4 root 2 can be divided by 4, so the 4's go on. And the 16 can be divided by 4, that's 4. So there's my like simplified answer. If you don't like that, if there's something about that that you didn't like, you can leave it, like I said. But this one's a little bit smaller, a little bit easier to work with. So another way of looking at this, you might have done it last year, is you common factor a 4 out of the top over 16, right? Because 4 times 2 is 8, and then the 4 goes in front of that too. Okay? So what does this mean? This means sine of x equals 2 plus root 2 over 4, and or sine of x equals 2 minus root 2 over 4, right? We good? And often you're going to be asked to do 4 decimal places, so we're going to keep a couple of extras. Bracket 2 plus root 2, bracket divided by 4 radians. Zero 0.853. Yep.
Do we not put the inverse of sine?
It's still sine x equals. So we will, yes. 853.553. I want 4 decimals. I'm going to keep 6. Probably 5 would be enough, but I'll keep 6 for now. Okay, and then I'm going to just switch this to minus 0.14644. How many is that? 7. And now this becomes a question like the last unit, where those are certainly not values that we can find the exact value of, right? It's not pi by 4, but it's, or sorry, not pi by 4, but like 1 over root 2 or root 3 over 2 or 1/2, right? But it's like that kind of a question where we would be doing sine theta equals 1 over root 2. You find the related angle, you think about the quadrant, all of that stuff. Does that make sense? So now we're going to do x, and it's going to be x related. These are both positive. So we're thinking quadrant 1 and quadrant 2 for both of them, right? Like you have to take that into account as well. So here's where I do, whoops, shift. Oh, but watch this. Oh, I turned my calculator off. So I'm gonna redo that. 2 plus square root of 2, bracket divided by 2, or sorry, divided by 4. And then I'm going to leave, like I wrote down 6 decimals, but I'm going to leave that on my calculator. As much as you can, that's a good way to keep exact answers, right? So I'll do shift sign, and then I'm sure you all know this, but use your little answer button. You should have one on your calculator for sure. And I get 1.02277. So I did round that. Yep.
If we came from like this like the fraction to this angle related with that, do we have to show like the middle part of like without the?
No.
No, so it can come from like the sine x to that. X
Yeah. And then that means quadrant 1 is going to be that, 228. And quadrant 2, I said this yesterday, in some cases you might want to split these up and show your answers and think about it. But in this case, it's easy for me to just do, again, I still have the answer on my calculator, and I just do pi minus that answer, and it gives me 2.1188. So because I didn't clear my calculator at all, that answer is pretty exact to 4 decimal places.
Would it be wrong if it was rounded slightly differently? Because I know you said how we don't have to show that middle line.
Right.
But if you had, let's say, rounded to the 0.85355, and then did the related angle from there.
So if you are asked for 4 decimal places, you should keep more decimal places than 4 until your very last step. When you're asked for 4 decimal places, what that means is your final answer. And, you know, whether you're one off, or it may or may not matter, right? Like in the real world, if you're building a bridge and you're off by 0.001 meters, you're off by like a fraction of a millimeter, that won't matter, right? But if you're off by 0.001 kilometers and you're building a bridge, that will matter, right? The bridge isn't going to fit, or it's not going to work, like there's going to be problems. So it totally depends in the real world on what you're doing. If you're building a rocket ship, you need to be exactly accurate in how you measure panels and they fit together to like more than a millimeter. That caused a bad accident decades ago now, where people died because a rocket ship, like 2 panels didn't fit properly and they lost compression or whatever, and it exploded, right? So it totally depends on what you're doing. So for us, I would say aim to be exact to 4 as best as you can. So if you're working and you're off by 1 decimal place, you got 1.0227, well, you know you just kind of didn't keep enough decimal places, and think about it for the next time, is what I would say. Like, it's not the end of the world, but because it's just math class. But it's a goal. It's a good goal that the ultimate idea is you should know how accurate your answer is. You should know, well, I rounded, so like this many decimals will be perfect. The other ones I'm not sure. Like, that's kind of what the best way for you to think about it is. Okay, but we're not done yet, because we have this answer, which is good too. We talked about this yesterday. Sometimes one of these, if it's bigger than 1 or smaller than -1, it's not a valid answer, because sign can't be that. But in this case, I got 2 that work, so I'm going to get 4 answers for this question. It's just the way that it worked out. So I'm going to go back to my calculator, and I don't think you need to actually watch me do it. I'm going to go 2 minus square root of 2, all divided by 4. Keep putting in 2. And that gives me this answer again. So I've got this answer back up on my calculator now. And then I'm going to, just so that I don't have to enter a round answer, you don't have to do it this way, but like I said, you do want to be able to understand what you're doing. So then shift sign of that, and that gave me 0.14698. And the nice thing about these 2 is that they were both quadrant 1, or sorry, they're both like quadrant 1, they're both positive, so quadrant 1, quadrant 2. So when I get the related angle, it's one of my answers. It does make life a little bit easier. And then, so the next one is pi minus my answer, and that works out to 2.9946. So there's my 4 answers. If it was negative and I had to go to quadrant 3 and quadrant 4, oh man, that would complicate things a little bit, because when I found one of the quadrant angles, I would lose my related angle. Like, it's just a little bit more complicated using your calculator. You know what I mean? But it's worth thinking about. As trivial as it seems, using our calculator, like we're good at that by now, it's still something you kind of have to stumble through. Like, I can imagine somebody who didn't do the practice, or maybe only did 1 or 2 of these and didn't get a chance to stumble with their calculator, and then on the test they do, could take you a lot longer to figure out, oh geez, this isn't working out. How do I do this again? What do I do? And kind of getting themselves confused and then maybe losing some confidence, whatever. Anyway, so I can imagine that if you hadn't kind of struggled through with your calculator a little bit beforehand, that could be confusing. Any questions about that? Are you sure? So same idea as yesterday, but you may or may not be able to factor. I would absolutely use the discriminant. It's something we're going to use a lot in the next unit to check if something is factorable. So it's a good idea to get used to that. It saves you a little bit of time if something is factorable, if you wouldn't catch it otherwise. But anyway, but when you need to use a quadratic formula, it does slow you down a little bit, and it makes it a little bit messier, calculator stuff in there. Otherwise, thinking and understanding is the same. Do you want to do another one together, or do you want to try one on your own? Like, if we do one together, I'm going to just kind of ask you to try it anyway, and then we'll take it up, or do you want to get started on the practice? The practice is question number 3 from the worksheet from yesterday. Same worksheet, you already have it. You can do question number 3 as well now. Okay, how about you can choose. I'll leave this up here, and you can, there is one thing I want to talk about with this one actually, but you can do this one all the way and we'll take it up in 10 minutes, or you can get started on the practice. Lots of time to practice today, and if anybody has any other questions from yesterday, they can ask me about that too. But before I let you go to that, start this one at least. Okay, take a look at it and think to yourself how you would approach the solving. It's a little bit different from the last one that we did. Claire, what'd you do for your first step here?
I switched everything to the right side.
Nice. So if anybody didn't notice that, I talked about this yesterday. It's funny how little things can make us think, oh, this one doesn't look like one Mr. Belair did. Maybe we do it a different way. You start making stuff up. There's no way, like, there's small changes in some of the questions, but there's no big other kinds of questions that I'm not going to show you. There's one more type that we're going to do Tuesday, but that's question number 4 if you want to look ahead. But for the most part, I'm giving you the idea of all the different kinds of questions. So we got to move everything to one side. You can move it to the left or to the right. It doesn't matter. So -2 sine squared x plus 10 cos x minus 1 equals 0. One of the reasons why maybe you think it's different is because cos is on one side and sine's on the other. So you're like, oh, maybe I can do something different. No, you can't. Okay, you can't. Now what do I do? Destiny. Okay, good. So some people started trying to factor it here. Whoa! This is like x squared plus a, or plus 4a plus 5 or something like that. Right? Like these are different. X and a are not the same. Sine and cos are not the same. Totally up to you. Of course you can, yeah. And so at this stage, I could also multiply everything by -1 or whatever. Like, yeah. But eventually, you certainly want your squared term to be positive. Factoring with a negative squared term is something we don't do at all, really. You can do it, but it's not familiar to us. It's a bad idea. Okay, so what is the Pythagorean identity that we're going to use? Very good. Plus 10 cos x minus 1 equals 0. So multiplying through, I get -2 plus 2. So in this case, it worked out to be positive anyway. Plus 10 cos x minus 1. And I'm just going to simplify a little bit. 2 cos squared x plus 10 cos x minus 3 equals 0. If I could common factor, right side's equal to 0, awesome, because I can divide it out. Like if all of these were evens, I could divide out a 2 and make my life a little bit easier. I would absolutely do that in this case. B squared minus 4ac is, b squared is 100, right? And then since c is negative, I'm actually going to be adding. So plus 4 times 2 times 3 is 124. What do we conclude from that? B squared minus 4ac is 124. Not factorable, but solvable. So I'm going to stop there, and I'm going to let you try this one if you want, or you can go ahead and get started on the practice. Okay, but we'll take this up.